First of all, what is a Lewis structure? A Lewis structure, or a Lewis dot diagram, shows you all the electrons, whether they're bonding or non-bonding. Sometimes we draw sort of Venn diagrams so that we can see that there are 8 electrons for this chlorine and 8 electrons for that chlorine. Another way that's acceptable to draw it is just to do a line, and each line represents a double bond. So there are 3 non-bonding pair electrons on each of the chlorines, and this one here is a bonding pair. Okay, so generally we're just trying to fill the octet, so whether it's a 2, 8, 8, whatever shell is the full shell for that element, and they will either do this by sharing electrons, whether it's evenly or, as we'll see later, a little bit unevenly. So the first thing you need to do is draw out all of the atoms in the question. So if the question was O2, I guess in this sense. If there are lots of other things like SO4, always put the extra bits on the outside. So if there's lots of H's, H2O, go for the H's on the outside. And if there's just a single atom, go for that as the central atom. So first of all, draw them out. Go to your periodic table and work out the number of valence electrons. And I'm only going to do this once, so I'll just skip to the periodic table here. And so the valence electrons, you just read along here. So for oxygen, there is 1, 2, 3, 4, 5, 6. Okay, so nitrogen would be 5. What else might we have? I think we have chlorine, so that would be 7. Okay, so just reading along here. So I won't go back to the periodic table. I'll assume you know how to work out the number of valence electrons now. And so valence electrons here, we draw them all out. 1, 2, 3, 4, 5, 6. The next thing you need to do is just draw one line, because if there's not one line, then it's not a compound, so there must be at least a single bond. Okay, now this is all the pre-work you do before you actually get the structure. So the second thing you do is now count them up to see whether it adds up to 8. So 1, 2, 3, 4, 5, 6, 7. No, that one doesn't add up to 8. And the other way around, 1, 2, 3, 4, 5, 6, 7. No, that one doesn't. All right, so if that doesn't work, you draw another line in, and then you can recount. So there's 2, 4, 6, 8. 2, 4, 6, 8. They've both got 8. So that must be the answer. So it must be oxygen must have 2 bonds and 2 non-bonding pair electrons. So that's that one. That's that one done here. So we could redraw it out. We can also do it like this. That is quite acceptable as well. Okay, so for the harder ones, if it still doesn't work out, you might want to consider a coordinate covalent bond where both the bonding pair electrons come from just one of the atoms, and we draw it in with a line. That's how we indicate a coordinate covalent bond. And so in this particular sense, it didn't make sense doing the third one, but it does make sense if we say that these two are a coordinate covalent bond, and there we have it drawn out in the classical way. And then this is really, that may be the structural formula, but that's not the Lewis structure. So the Lewis structure for that would be a lone pair here and a lone pair there. So there's 2 different types of Lewis structures. Okay, so just exceptions to the rules. You can see beryllium and boron are actually very, very small. They only have, 4 and 5 protons. So they can't actually fit that much stuff around them. Larger atoms can fit lots of stuff around them. Smaller atoms can't fit that much without electrons repelling them. So there are exceptions to these octet rules, and even larger atoms can fit larger bits on there, but we're not doing that for ATAR. And so beryllium can only fit 2, and boron here can fit 3. So there are exceptions to the rules, which is a little bit nasty. And I'll just go through some examples. So that's how you do it. So let's just do some examples. We've just done these 2. Nitrogen's a good one because it's a triple bond. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It doesn't actually matter where you put these things. 1. So that counts up to 1, 2, 3, 4, 5, 6. Not good enough. Okay, 1, 2, 3, 4, 5, 6, 7. Still not good enough. 1, 2, 3, 4, 5, 6, 7, 8, and this one is the same as well, so that must be the answer. And so you can see you've got, this is your Lewis structure. Okay, this one here, carbon 1, 2, 3, 4, hydrogen 1, nitrogen 1, 2, 3, 4, 5. Must draw one bond in each first. The hydrogen has 2, so that's good. Carbon has 1, 2, 3, 4, 5, 6. Needs 8. Nitrogen has 1, 2, 3, 4, 5, 6. If we do that, they have 7. If we do that, they have 8. And so that's the answer. So it looks like that. Okay, that's the Lewis structure. There's quite a few more here. I'll let you go ahead and do those. I'll just do one of these perhaps. Carbon, 1, 2, 3, 4, 1, 2, 3, 4, hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1. Must have the single bonds in there first. And all the hydrogens are happy. The carbons have 1, 2, 3, 4, 5, 6, 7. They both have 7, so let's, have to join those two together. And then we have 1, 2, 3, 4, 5, 6, 7, 8. So they have full electrons. So now we can draw that out properly. Okay, so that's how you do them. I'm going to leave the rest for you, and you can Google the answers for that as just practice problems.